boys and girls. I'm going to show y'all how to do assignment number 1, binary ionic compounds. Binary means there's 2 elements in the compound, just 2 elements. Ionic means you have a metal and a non-metal, and their opposite charges attract. Okay, hopefully you watched my dance video and you remember the dance moves, symbols, oxidation numbers, crisscross, and simplify. So I'm going to go over these steps and show you how they go on worksheet 1. Come on, let's go. Okay, so here we are, assignment 1, binary ionic compounds. I know it doesn't say ionic on there, but it should. Okay, so let's go over our steps real quick. If we're going from the name to the formula, step 1, we're going to write the symbols. Remember, the metal always goes first. Always goes first. Okay? That's okay, the metals don't mind. Metals go first. Step 2, we're going to write the oxidation number. This is the charge that an element makes when it becomes an ion. Remember, ions, we're gaining and losing electrons. Metals lose electrons to form positive ions. This is why I told you guys you want to have this written on your periodic table. Above group 1, you want to put +1. Above group 2, you want to put +2. In other words, if you're in group 1, you're going to form a +1 ion. If you're in group 2, you're going to form a +2 ion. Now, all our transition metals here, we're going to skip them, but we're going to cover them in assignment 2, and you're going to find out about them. Come all the way over here to group 13 or 3A. These are going to form +3 ions. Okay? Then in group 14, we put plus or minus 4. That's because they can gain 4 or lose 4, and actually, they don't. If you're in group 14, you are more likely to form a covalent compound, although sometimes you can. And the metals, tin and lead, sometimes they form +4 ions. But we're going to talk about these guys in assignment 2. But here we go to group 15. And group 15 gains 3 electrons and forms a -3 ion. So you should have -3 above group 15. Group 16 is going to gain 2 electrons and form -2. So you should have -2 written there. And of course, the halogens are going to gain 1 electron and be a -1. So basically, when you see these here in green, they're going to form -4, -3, -2. And these in brown are going to form -1 ions. Okay? And so those are your non-metals forming negative ions because they're gaining electrons. Step 3, we're going to crisscross. In other words, the superscript of the metal becomes the subscript for the non-metal. And the superscript for the non-metal becomes the subscript for the metal. This will make sense once I start the worksheet. And of course, step 4, we're going to simplify. If we have a 2 and a 2, we can both divide those down by 2 to 1 and 1. All right, so let's just get started on the worksheet. So basically what we're going to be doing in this unit is I'm going to give you the name of a chemical and you're going to tell me its formula. Okay, and over here, I'm going to give you the formula and you're going to give me the name. So we'll work on this side first, okay? So sodium, the symbol for sodium is Na. Chloride, we put the ending "ide," that means chlorine. When the nonmetals become ions, they get "ide" added to their name. We're going to cover that over here on this side. So chloride means chlorine, okay? Now we put the oxidation numbers as superscripts. This is where you use your periodic table, and we see sodium is in group 1, and it has a +1. So we put a +1 up here. Sometimes people just put a plus sign to mean +1, but if you want to write +1, you can do that as well, but a plus sign is what the cool chemists do. All right, and chlorine is over here in group 17, and it's going to form a -1 ion, so we put a -1 here. All right, now here's where the magic is going to happen. This is the crisscross step. Okay, so what's going to happen is this number here for the nonmetal comes over here, and we drop the sign. There are no plus or minus signs in chemical formulas. And this number here comes over here, and we drop the sign. Also, we don't write the number 1. So this is just going to be NaCl. So, sodium chloride is the name. NaCl is the chemical formula. All right, let's do the next one. Aluminum bromide. Aluminum is Al. Bromide, well, that means bromine, another halogen. Now let's look at our charges. Aluminum is in group 13 or 3A. It's going to form a +3. The cool chemist put 3+, but if you want to put +3, that's fine. And bromine, well, it's also a halogen, and it's going to form a -1. And so now we know this 3 is going to come over here, and the 1 comes over here, but we're not going to write the 1, are we? No, do not write 1s in chemical formulas. Okay, and so we write AlBr3. In other words, what we're going to need is we're going to need 3 -1s to counteract the 1 + 3. If we were to look at these ions, we would see here's an aluminum ion with its +3 charge, and we would need +3, ding, 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 -3 equals 0. The net charge, I'm sorry, I was off the camera there. The net charge of an ionic compound has to be 0. Aluminum's +3, each bromine is a -1, +3, -3, 0. That's one of the key things about ionic compounds, is the net charge is going to equal 0. Okay, the positive and the negative charges are going to cancel. Okay, calcium nitride. Calcium is Ca. Nitride means nitrogen. Let's put nitrogen there. Okay, we look and we see that calcium is in group 2. It's going to form a +2 ion. Nitrogen is in group 15 or 5A, and it's going to form a -3 ion. All right, step 3, we're going to crisscross, and this 2 comes over here, and we're going to drop that plus sign. Remember, you drop the signs as if they were hot, and a 3 comes there. Now, can we simplify 3 and 2? Can we divide them by the same whole number? No, we can't. So this is the lowest whole number ratio these 2 ions can combine in. So we write the formula as Ca3N2. All right, radium oxide. Radium, for those who didn't know, is right here at the bottom of group 2, and its symbol is Ra, and it's going to form a +2 ion. Oxygen is here in group 16 or 6A, and it's going to form a -2 ion. Step 3, we're going to crisscross. This 2 comes over here, and that 2 comes over there. Remember, we dropped the signs as if they were hot. Now, we see a 2 and a 2. Can we simplify that? Yes, we can. We can divide both of these by 2. And what's 2 divided by 2? Did you say 1?
Yes.
All right. So we can say that their simplest whole number ratio that they can combine in is a 1-to-1 ratio. And so that's our formula there. So if we were to look at the ions, we would see we would have a radium ion and it's a +2. And we'd have an oxygen ion, and it's a -2. Well, how many oxygens do we need to counteract that +2? Just one. They combine in a 1-to-1 ratio. Radium oxide. All right. So I'm going to skip down to number 8 because there's something here that's kind of weird that you probably never ever see again. But you see that our nonmetal is called hydride. Well, every once in a while, very, very rarely, hydrogen, instead of losing one electron like it normally does and forming a +1 ion, sometimes it'll gain an electron. So if hydrogen has 2 electrons, its outer shell is full. And so the hydride ion is H with a -1 charge. And of course, sodium is a +1. And some of y'all can already figure out what's going to happen here. Cross over here, 1, cross over there, 1. That's going to be a 1-to-1 ratio, and the formula for this one is going to be NaH. All right? So that's how you do name to formula. So now I'm going to skip over here. You can do the rest on your own, and I'm going to do formula to the name. This, guys, is the easiest part of the whole unit. It is so easy. Because really all you have to do is 3 simple steps. Okay, so step 1, you're going to write the name of the metal. Remember, the metal goes first. Very important. Metal goes first. Step 2, you're going to write the name of the nonmetal. But we're going to change the ending of the nonmetal's name to "ide." We're going to "ide" them. In other words, chlorine becomes chloride. Oxygen becomes oxide. Fluorine becomes fluoride. Now there's a couple of them that you have to look out for because they're kind of weird. Sulfur becomes sulfide, not sulfuride. Uncool. And phosphorus becomes phosphide, not phosphoride. Okay, so hopefully you can remember those. And let's look at this here. Okay, and see, we see the symbol of Ca. What is Ca? Did you say calcium?
Yes.
All right. So we write calcium. And the symbol O, what is that? Did you say oxygen?
Yeah, baby.
All right. So we just put oxide. That's it. So what's Al? Aluminum. Unless you are from Australia, then it's aluminium. Are any of you from Australia?
No.
Okay. All right. And S is sulfur. Am I going to write sulfuride?
No.
I'm going to write sulfide.
Yeah.
And that's it. That's so easy to do. Na is sodium. And I is iodine, but we write it as iodide. All right, let me know if you have any questions. I'm going to post the key to this here very soon. And hopefully you'll get it right. Take care. Email me. Contact me if you have any questions. Bye.